And you'll remember that we are focusing this week on evolution in the present times. I'm providing you with evidence that evolution is not something that happened long ago and has stopped happening, but that in fact it happens today. We've looked at insecticide resistance and antibiotic resistance, and today we're going to focus on island species as an example of evolution happening right now. Do you remember what is meant by allopatric speciation? In allopatric speciation, we had new species evolving because a population was split by some geographical barrier, such as a mountain range or the sea, or even an urbanization. We could have a population that was split by the building of a highway and the developing of suburbs and cities. So whereas we had a population at time 1, we've now got the original parent population and split off and no longer in contact with the parent population is another small population made up of members of the same species as present in population 1. Now that would be fine if environmental conditions in this new area or this new ecosystem were the same. But if environmental conditions have changed, then we will find that we no longer have the same pressures in population 2 that we had in population 1. We've got environmental conditions of one sort for population 1, but we have a different set of environmental conditions for population 2. And so population 2 has to adapt to those very new and very different environmental conditions, and it is in adapting that we see evolution taking place. And this kind of evolution is known as allopatric speciation. The speciation of Darwin's finches and the Galapagos tortoises happened in this way, allopatrically. Now, I need to provide you with evidence that shows allopatric speciation in what we now call island species. It might not be on an island, but if we've got an environment that has been separated allopatrically from a parent population, we have in effect created an island. Now, I need to provide you of evidence of this happening today. We can see certain examples like the finches, like the Galapagos tortoises. We can see all of these that have happened in the past. But can I show you island species evolving today? All right, this is a very beautiful little bird with, in my opinion, a rather unfortunate name. It is called the European great tit. Now, I want you to try and stop laughing at its name and focus on this as an example of evolution happening in an island species right now. Now, the European great tit lives in rural areas naturally, but it's quite happy to adapt to city life too. However, recently it has been found that the males of European great tits that live in the city sing at a higher pitch. than those that live in rural or countryside areas. Why do you think this might be? Well, it has been suggested that the noise in the city makes it difficult for the birds to hear their normal song. And remember that the song is not produced simply to show that the European great tit is a happy little bird. The song is used to attract mates and also to establish territory. It is so important that the other European great tits can hear the song. And if there's too much noise, they're not going to be able to hear it. But if the male can change the pitch or can sing at a different pitch, then it could be that females and other males are able to hear it. The consequences of singing at a higher pitch mean that the male that is singing at a higher pitch is going to get a mate, is going to establish its territory, is going to be able to survive, and is going to be able to produce more offspring. Now, it wasn't that one European great tit just decided to sing at a higher pitch. The pitch is controlled genetically. It is a gene that controls the pitch at which the bird sings. All it would have taken was a few birds to have a mutation that allowed them to sing at a higher pitch. Now, normally, if they were singing in the rural area, in the countryside, the higher pitch wouldn't have really been an advantage at all. But suddenly, in the city, where they need to be heard, the higher pitch is, all of a sudden, an advantage. And therefore, those males that can sing at the higher pitch are going to get the mates. They're going to survive and they're going to produce offspring, and of course the offspring will have the gene for higher pitched song. It is possible that the population of the European great tit in cities will become reproductively isolated from the population in the country because their song has become different. And if you took these new higher pitched individuals and you returned these higher pitched singing individuals back to rural areas or back into the country, if they could no longer mate, you would find that you have a new species of bird that has evolved simply through reproductive isolation.